In solving trigonometric equations, there are quite a few steps that we need to go through. So perhaps it's best to look at the example on the next page. If we think about this example here, where it asks us to find the solutions to the equation sine x is equal to 1 on root 2, let's look at the part here where we are going to draw the graph of sine x, and then we're going to draw a straight line through 1 on root 2, that is y equals 1 on root 2, and see what we end up with. So first of all, we've drawn the graph of y equal to sine x. Remember, y equal to sine x has a period of 2 pi on 1, which makes it 2 pi, and an amplitude of 1, which means y is between -1 and 1. The other line that we're going to draw there is y equal to 1 on root 2. And if you were to work that out, it's around about as a decimal 0.7071. So if I'm going to indicate that on my graph, that's where I will be drawing my line. Okay, so you can see there in our domain, which is between 0 and 2 pi, we've got one cycle of y equal to sine x, and where do those two things meet? They meet there and there. So I've actually got two solutions in that domain. Well, how would I go about doing that algebraically? Okay, so algebraically, I'm going to work out what quadrants my answers are going to be in. And the way that I would do that is I look at the original question here, sine x equal to 1 on root 2. 1 on root 2 is a positive 1 on root 2. And where is sine positive? It is positive in the first and the second quadrant. So that is where my solutions are going to be. Okay, the next thing that I need to do, and I call this the basic angle. Basic angle is bringing everything back to the first quadrant. So I always deal with sine x 1 on root 2, so it should always be positive and it should always be a single angle. And we'll look at that a little bit further down the track. So sine x equals 1 on root 2. And if I use my exact values table or my triangles, I get x is equal to pi on 4. Now that is an angle in the first quadrant, and that is my basic angle. What I now need to decide is whether or not that is one of the answers that I'm going to accept. Where are my solutions? Well, we talked about the fact that they are in the first and the second quadrant there. So I am going to accept that answer in the first quadrant. So x is equal to pi on 4. That's my first solution. Now, in the second quadrant, do you remember what the actual relationship was? Pi minus x. So remember, my x is pi on 4. So here it's going to be pi minus pi on 4, which means my solutions are pi on 4 and 3 pi on 4. If I come back up to my graph, therefore, this solution here is the pi on 4 one, and this one here is 3 pi on 4. So my graph verifies my algebraic answers, or my algebraic answers verify my graph. Now, I do not have to draw a graph every time I'm asked to solve something. I just need to do it algebraically. So let's have a look at this one. Sine theta equals minus root 3 on 2, and theta is between 0 and pi. So if I think about what quadrant I'm in there, remember, I'm between 0 and pi. If I was looking at my quadrants, that is 0, pi on 2, and pi. So I'm really only going halfway around my circle. But I know that sine theta, which I'm looking for negative answers, because it's negative root 3 on 2, whereas sine theta negative, it is negative in these quadrants here. So, are there any solutions between 0 and pi that are negative? The answer is no. So, in actual fact, there would be no solutions there. Here's the same question, but this time we are going over a different domain. We're going between negative pi and pi. We're going to start off exactly the same way by checking out what quadrants we're in. Now, if I go to pi in the positive direction, so let's just go 0 to pi at this stage, again, we know that sign, and we're dealing with a negative sign, there's no answers in that domain. Now, when we talk about negative pi, we're going in that direction. So negative pi, are there any solutions there? There are 1 and 2. So therefore, I'm going to have 2 solutions. Let's have a look at how that works. My basic angle is sine theta. And remember, when I'm talking basic angle, I want an angle in the first quadrant, so it has to be positive root 3 on 2. And I know that using my exact values table or my triangles, that sine theta equal to root 3 on 2, theta is going to be equal to pi on 3. So that's my basic angle. That's my angle in the first quadrant. Now, going forward, do I want anything in the first quadrant? And the answer is no, because my solutions would be in the third and fourth quadrant. But I'm only going as far as pi. So therefore, I'm not going to accept anything going in the positive direction. In the negative direction, now let's think negatively. This is what you need to think about when you are going in the negative direction. Let's go back and have a look at positive as well and compare the two. So when I go around in the positive direction, all right, I say theta, pi minus theta, pi plus theta, 2 pi minus theta, or 2 pi minus x, depending on what you're using. In the negative direction, all right, so that's going around in that way. In the negative direction, I'm going around that way. I start here with theta, but it's minus, and I'm going to put a minus in front of everything. So if you think about this, this is pi minus theta here, but it is negative. And what's the next one? It would be pi plus theta, but I make it a negative. And 2 pi minus theta, and again, I make that a negative. Now, where are my solutions for this one? You know that my solutions are in this quadrant and this quadrant. And I know that theta is pi on 3. So therefore, theta is going to be equal to minus pi on 3, because it's minus theta. And the next one is going to be minus of pi minus pi on 3. And what does that give me? Well, minus pi on 3. And this one here, pi minus pi on 3 is 2 pi on 3. And so that becomes minus 2 pi on 3. So going in the negative direction can be a little bit tricky. I would suggest that we always try to remember this diagram. So how is this question different to what we've just done? We've just looked at sine theta equal to minus root 3 on 2 between minus pi and pi. Well, because of this 2 theta, we do have to be very careful. So we know theta is between minus pi and pi, but this now means that I have to times everything through by 2, because 2 theta is between minus 2 pi and positive 2 pi. So if we're checking out our quadrants here, yeah, you know that because I'm going all the way around and I'm wanting sine theta to be negative, in the positive direction, my solutions are there. And in the negative direction, my solutions are there. So they're in exactly the same spot, the solutions, but the light blue ones are when we go in the negative direction, and the dark blue ones are when we go in the positive direction. So we need to get that down straight. All right, how do I then go about this? I need my basic angle. So the steps are the same. My basic angle, I don't want a double angle. I always take the sine theta, and I always use a positive because I want something that's in the first quadrant. And we said that theta was equal to pi on 3. That's my basic angle. That's the angle in the first quadrant. I now need to work out my actual answers. Do I use that one or don't I? Well, again, because of this 2 theta, it's not theta equals, it is 2 theta equals. And my first solution, if I go in the positive direction, is this one here. All right, and that is pi plus theta. So it's pi plus pi on 3. And this one here is going to be 2 pi minus pi on 3. Let's have a look at the ones going in the negative direction. And I'll do that in a different colour so that we can see them. So going in the negative direction, I've got this one here. And so we talked about that being minus theta, so minus pi on 3. And then the next one here is going to be this one, which is minus pi on 3. Let's tidy that up, and I get 2 theta equals pi plus pi on 3 is 4 pi on 3. 2 pi take away pi on 3. Remember, 2 pi is 6 on 3, so 6 take away 1 is 5 pi on 3. And I've got minus pi on 3, and pi minus pi on 3 is 2 pi on 3, so it's negative 2 pi on 3. And I'm nearly there. I don't want 2 theta, I want theta, which means I need to divide everything through by 2. So I get 4 pi on 6, 5 pi on 6, minus pi on 6, and minus 2 pi on 6. And what I'll do is I'll put them in order from smallest to largest and simplify them where I can. So what is smaller, minus pi on 6 or minus 2 pi on 6? Hopefully you're saying minus 2 pi on 6. So that becomes minus pi on 3, and then minus pi on 6. And then we go 4 pi on 6, which is 2 pi on 3, and 5 pi on 6. And they are my 4 solutions between negative 2 pi and 2 pi. So there are a lot of things to consider in that example. The double angle there, the fact that that will affect not only my domain, so it changes my domain, but it also means that in the end, to get my solutions, I've got to divide through by that particular value. If you now notice the solutions that I've got there for theta, remember my original theta was between minus pi and pi. So these answers that I have here should be within that domain. And are they? Is minus pi on 3 within that domain? Is 5 pi on 6 within that domain? They are, because if they weren't, then I've done something wrong.